We use literals to assign values to variables. So for example, here we have a variable radius of type float, and we set that equal to diameter divided by 2, whereas that value 2 is the literal value. Or int age equals 19. 19 would be the literal value. Anytime you have a numeric literal, like 19, as long as there's no decimal point on it, it's assumed that that's an int, so a 4-byte whole number. If you want that to be a long, an 8-byte number, then go ahead and drop a letter L at the end of the literal. Normally we'd use a capital L there. Lowercase is allowed, but that looks too much like a 1. So capital L would be typical to use if you have a very large number that you want to use as a literal. Just drop that L at the end. One of the newer features that just came out in Java 7 is that you can use an underscore within your numeric literal to kind of break it up and make it easier to read. And so this world population entry, that big number all squished together with the L at the end, that's kind of harder to read perhaps than if you use a few underscores to serve as separators between the thousands, the millions, and the billions here. Anytime you have a literal that has a decimal point in it, the assumption is that you're working with a double, double precision 64-bit number. So here we have circumference equals 47.25. So that literal to the right would be a double as its data type. If what you want is that literal to be considered to be a floating point, then use a letter F at the back end of it. Again, we tend to use capital letter here, but lowercase would be fine. So height equals 43.8 and then the F. If you omit that letter F, it would be as if you're trying to take an 8-byte number, 43.8, and store it into a 4-byte variable, a double into a float, and that wouldn't work. And so when we're using literals, you're going to want to drop a letter F at the end of your numeric literal with a decimal place if you truly are working with a float. They actually allow you to use a letter D, 47.25D, if you want to just be really clear, really explicit that it's a double, but most people don't do that. It's pretty rare to see that in the Java code you run into. Normally omitting the letter D means it's a double, adding the letter F indicates float. And as the last point mentions here, you can also use exponential notation. That's allowed as well when you're declaring your literal values. And so just trying a couple of these here just to kind of see how it works. I've got int age equals 12 here in this example from a few pages back. That 12 would be an integer literal, right? But if I put the letter L afterwards, it's not going to compile for me. Why not? What's wrong with this? Well, if you kind of think through, the number 12 is going to be a long, which is 8 bytes, and you're trying to store it into a variable type int, which is 4 bytes. And so the error you're going to run into says it can't convert from a long to an int. Can't make that conversion. And so if we really wanted to leave the literal as a long, we need to change the variable to be a long as well. And now it compiles cleanly. How about if we went with a double? Double age equals 12.5. Sure, that's perfectly fine. That compiles nice. A number with a decimal is always double precision. And as I mentioned, it's legal to put the letter D in there, although you won't see that too often. If I switch this to type float, though, then we'll see a similar kind of error as we saw before when trying to store a long into an int. This is now saying you can't convert a double to a float. A double is 8 bytes, a float's 4 bytes. They just don't fit together. To get around that, we use the letter F, 12.5F, and now the thing to the right of the equal sign is a 32-bit float number, and the thing to the left is a 32-bit float data type. So the common thing we see when we're programming Java is we do something like float age equals 12.5 semicolon, and we get an error message. Well, it's because that literal value with the decimal is considered to be a double unless you use that capital F afterwards to specify that we're truly meaning that for that to be a float. On your own here, as we wrap up this page, feel free to load up volumes.java. This is another one of those programs that's in your Chapter 4 directory. Maybe walk through it, take a look at the code, see what it's doing, run the code if you'd like. just to get a feel for working with various different literal values. And you'll see lots more examples here of variable declarations as well.